Hey, y'all. Good afternoon, y'all. Well, good evening, rather. Um, I'm having a little bit of video issues in going to creating videos for my lesson, so I'm going to do something a little bit different today. All right. Still gonna be filming, but things gonna be done a tad bit different. So let's go ahead and get this show started. All right, y'all. Let's go ahead and get into it. In this video that we are doing, we are factoring, but not the factoring that you are very familiar with, but you going to use the stuff that we've been doing to take care of today's learning objective. All right, let's run through this. So guys, let's talk about it. Before we get into this, we got to go over a few things so we could be well prepared. Guys, let's talk about the greatest common factor. We should know what greatest common factor is, meaning the largest factor that other two numbers have. For example, ooh, what am I doing? There we go. Let's do the first one right quick. I'm doing them. 6 and 8. 6 and 8 have the greatest common factor of 2 because 2 times 3 gives you 6 and 2 times 4 gives you 8. But they also have a factor of 1 as well. But 1 is just too small because 1 times 6 gives you 6, but 1 times 8 gives you 8. And you're looking for the biggest factor both 6 and 8 have. All right, let's just do number 2. And 3 and 4, I encourage you to kind of try out on your own and see me outside class to discuss these answers. 5 and 30, what do they both have in common? Largest numbers. So they have both a 1 because 1 times 5 is 5. And 1 times 30 gives you 30. But 5 times 1 gives you 5. And 5 times 6 gives you 30. So the greatest common factor of 5 and 30 is, well, 5. All right. But let me ask you a question about 2 and 5. What type of numbers are those? Those are prime numbers. So remember, prime numbers are numbers that only have factors of 1 and itself. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 4 cannot be a prime factor because 4 times 4, 2 times 2 gives you 4, and 1 times 4 gives you 4. 5 is 1. 1 times 5, not 6, 7. 1 times 7. Yeah, don't make the mistake of thinking that prime numbers means that they gotta be odd. That's not always the case because 2 is not a odd number, it's even, but it's a prime number. All right, let's move on, shall we? All right, so greatest common factor. You use that same knowledge that we just did and to apply to here. 6a plus 20, the greatest common factor of those two numbers. And you could go ahead and look at it, 6 and 20. Well, 1 times 6 gives you that. 2 times 3 gives you 6. 1 times 20 gives you 20. But 2 times 10 gives you 20. So the greatest common factor is 2. So you pull that out, side, get you a set of parentheses, plus 3. Get the A in there, plus 10. Now to check your work, just use distributive property and put it back in. 2 times 3 is 6A. 2 times 10 is 10. It's 20. And voila. On the second one over here, 24, 18. Greatest common factor of 24, 18. And you could just list all the factors of 18. 1 and 18 is 1. 2 and 9. 3 and 6. What about 24? 1 and 24. 2 and 12. 3 and 8. And 4 and 6. So the greatest common factor is 6. Could they have the biggest numbers that both 24 and 18 have is 6. So pull out 6. 6 times blank gives me 24. 4. And don't forget, because I have the x squared, I gotta put that in the inside the parentheses because it has nothing in common. Plus 6 times blank gives me 18. 3. Just like that. These skills going to build up to what we had to do today, what we've been doing. All right, guys. Okay, so this question, I'm going to touch on it a little bit, but this is going to help us talk more about polynomials because we've been talking about polynomials. Guys, is this a polynomial? Why is it a polynomial? The degree, I use n, and it could be whatever number I want it to be. And has to be greater than or equal to 0, meaning that the degree must be greater than or equal to 0. My degree in this case is 2. Also, it has a binomial because it has 2 terms, 1, 2. Because it has 2 terms, it's a binomial. Two terms. And that's going to be essential for your quiz that you must be aware of. All right, let's go ahead and proceed on. So let's recap our long division problems that we've been dealing with. So let me ask you this. Do I really have to do long division on this problem? No. Well, why not? I swear I think I have to. Because what? You are right. They do have greatest common factors. So let's go ahead and rewrite this and let's see. So what is the greatest common factor of all of these terms? Well, you're right. Something about r minus 10, right? Something about that's going to happen. So let's look at the numerator before we answer the question further about greatest common factor, what they all have. You're right. They are going to have they're going to have an r minus 10, both in the numerator and the denominator. So what gave it away? Well, look something like this. It has your denominator right here. So that means whatever I have in my denominator, I need to determine why I have that r minus 10 in my numerator too, especially when I factor. So let's do it in the numerator. Greatest common factor of 7r squared minus 70r squared. What do they have in common? I'm looking at the numerator. 70r. 7r squared minus 70R. They have a 7R in common. So I'll pull that out. And wherever I don't have in common, like I did before, I put in the parentheses, R squared minus 10, right? So let's double check our work. So when we check our work, well, it doesn't, I made a mistake with the R squared. They have an R. Just like it's easy to get that wrong. So let's see when I do distributed property, will I have the same as I initially had it in the numerator? So let's find out. So 7R times R. What do we know about when we multiply and when we're dealing with exponents? Well, we know that R by itself has the power of 1. And when you multiply, you add them together, so it gives you 7R squared. And then minus 70R. That's the same as I had in the numerator. So now with that being said, let's go ahead and pull this together. 7R. So 7R is the thing that I pulled down in front of the numerator. So R minus 10. And y'all gotta forgive me about my handwriting. I know my R's look like these. I have an R minus 10 here. So you're right. The R minus 10 cancels out. So my answer is just 7R. And again, anytime you guys see me draw circles in the formation of a triangle, that means I'm done. That's my final answer. And I'm not changing my mind over it. All right, let's move on. Guys, I want you to try this one out on your own. We're going to try this one out. And of course, I want you to kind of have a conversation with me and, discuss these things. So let me ask you this. Am I going to use long division on this one? Well, are you sure that I don't have to, that I can't factor stuff out? I mean, they do have M's in common everywhere. They have M here, an M here, and an M there. Why can I not just simply just factor things out? Well, my coefficients don't have nothing in common with 5. I mean, 20 and 5 do, but 9 and 49 does not. So I'm gonna have to use the long division method. It sucks to have to do all that, but guess what? We're gonna have to do it. Well, you're gonna have to do it. And I'm gonna keep it pushing. All right. Awesome job, class 4A and 1B. I'm giving you guys a shot because throughout the cahoots that we have did so far, there's always someone in these two classes always been on top. So awesome job, good everything. I'm thoroughly impressed. All right. All right, guys, before we go further, I wanted to address this to you guys because you teenagers and you guys were like, ugh, I'm so over math. I can't take it. So look, in math, there are two different types of math. Let me say that. Two different types. One is abstract, one is applied. Abstract means that you can't touch it. You can't touch. Applied, you can touch it or do something with it. Like, for example, remember I was telling you something about a rational number? And also, guys, I use this letter Q to say rational number of P and Q. You see all those letters? Those letters got something to do with your everyday life? It does not. So I want you guys to understand, you know, this is just a fine example of it. But applied version of a rational number is dealing with ratios like 5 to 4. And 5 to 4 could be people to dogs. That's something that you can touch because you can touch a person, you can touch a dog, although you may want to be careful with all the viruses we got to deal with. But again, the stuff that you're being taught, you're going to be dealing with the abstract math. That means you're going to be dealing with a bunch of letters and you're going to have this headache. You're going to be like, oh my God, I'm so dizzy. And then when it comes to the applied stuff, which we will do, but not as often as you will want, you'll be all right. So let's go ahead and move on. Reminders. You guys got a quiz next week. Bring your notes. We watch videos. Projects due September 2nd. Guys, keep up with all your Google Classroom information. Even if you gone, even if I don't in class go to Google Classroom, I need for you to constantly check it all the time. Even if I don't say nothing to you about. All right. Factoring with special cases. Now, we did a lot of factoring already with binomials, and we did a lot of factoring also in terms of doing our long division. So we've been at this for a while now. But guys, there may be some different cases where it may not always where we got a factor. And our factor notation is going to look like this. These notations is something you must be able to know and do on your quiz. Let me give you an example of something. So remember in the previous class, I gave you something that looks like this. That's a trinomial, by the way. A trinomial is just mean 3 terms. You got 1, 2, 3 terms. But more on that later. So I gave you a quadratic that looks like this. And its factor form, again, what two numbers when you multiply together gives you 6, and the same two numbers when you add them gives you 5. So x plus 2, x plus 3. Because when we do our foiling method, we get x squared plus 3x plus 2x plus 6. And when we combine our terms, we get something that looks like this. X squared plus 5x plus 6. This is the format, how we write our factor and our standard forms of quadratics. So what if I give you a factor form of this? And I want you to have your final answer to look like this. And you see this example right here, while I'm highlighting with my purple? This is all abstract. Again, you can't see and touch. It's more of a thought thing. So let's factor these numbers. So x times x, which is x squared, x times 3 plus 3x, negative 7 times x, minus 7x, negative 7 times 3, minus 21. Combine your terms, you get x squared minus 4x minus 21. This format is the same as this. That's the standard form. And this right here is your square or factor form. So you notice that I wrote it like this. Guys, this is the same actual format of x or a minus b format. This is another way of rewriting your factor form. All right. But today, we're going more in terms of perfect squares. So you're dealing with the difference and sums of squares. So 4 is a perfect square, right? 9 is a perfect square. So this is the square format, which is the factor form of this. So this is equal as m plus 2, m plus 2. So that's the same as that. But this is called the square form. This is the square factored form. And this is just regular factor form. So let's go ahead and find the square. To do that, we got to go from here to here. But now we have to use our foiling method that we know to put it in the standard quadratic form. So let's do that. So m squared plus 2x, 2m, plus another 2m plus 4. Again, 2 to the power of 2 is 4. So you got to keep those things in mind, all right? So combine those, you get m squared plus 4m plus 4. And that's how it looks when you're dealing with it on the plus side. All right? And this is finding the square. So we call this the sum of squares. All right, so let's move on to a different case. So what if I have a situation like this using my foiling method? So let's go ahead and do it. 16y squared minus 4y, well, plus 4y, then minus 4y minus y. Anything, what's going to happen? My positive 4y, negative 4y cancels out. That's going to be 16y squared minus 1. And if that is the same as saying a squared minus b squared. And that is more so dealing with your difference of squares that you may want to keep your mind of, all right? You could write like this, or you could say a plus b, a minus b. This is the same as that. They're basically all the same. All right, let's keep going. Again, kill the replay if you need it. All right. Let's try simplifying our work over here. So this is a square form, so you could write it as a difference of squares. Actually, I want you to try this one out on your own. Just see what could happen. So when you do that problem, you should have an answer that looks like this. So I want you to try that one out. I'll do it with you. Let's just be fun about it. So in this case, let's go ahead and do it. Because you got two 4r's, so 4r squared is the same as this. So let's FOIL it out. So we get 16r squared minus 16r minus 16r plus 16. So when you combine, your final answer is going to be 16r squared minus 32r plus 16. All right. And this is for factoring. Okay, we just did the factoring techniques of that. All right. So let's make sure that we got answer look the same. So again, we have our work look just like that. All right. So let's go ahead and deal with this. So if I say cube, like if I'm saying 3 cubed, what am I saying? 3 times 3 times 3, which is 27 cubed. So yeah, let's try this one out. So these are the same as dealing with the squares you had dealt with. All right. So let's do this example right quick. So I'm going to do this for you. So in order for this to be equal to all of that, I know I have to use w plus x. That's why I know that I have to do. Only because when I do that, and of course you're going to have to use your formula method, your answer is going to get to this guy right here. But I would discuss this a little bit further along the line in the class, or I will make another video pertaining to this detail. All right. Because I know it is very abstract, that's why. So let's try the other piece. All right. So with this, when you're dealing with this particular problem, oh my, I don't have room to do all that. And Jesus. All right. So this is what I'm going to do for you guys. In the class, we're going to work this out in detail. And then I'm going to post another video dealing with those particular pieces. All right. It's only because these kind of problems actually need the additional work they need to do all of this. All right. So I want to try this one before I go, and then we're going to call it quits from there. All right. So again, these are your sum and difference of cubes. All right. So I'm going to factor all this and show you how it should look. Because basically, we gain this and we have to have it equal to this. All right. So let's go ahead and try it. So we do have a formula method to attend to. Well, this is a different form because you're dealing with cubes. So take your W's and multiply them everywhere you see. So it's going to be W to the power of 3 minus W squared, because of the two W's, I have X plus X, or WX. WX squared. All right, see how I did that? I took the W's and multiplied them in all those pieces. All right, so now changing my color, I'm gonna do this again. This time we're gonna take the x's. So x times w squared is going to be a positive w squared x all right. And then from there, I do it again, plus w x squared. Well, that's minus, I'm tripping. Minus plus s cubed. All right, so guess what? We got some things that could cancel out, can they? Oh, I gotta forget to draw my arrow so you guys could visually see how I got those. All right, let's go ahead and make some things happen, y'all. Make some magic happen. Well, guess what? We got some things that could cancel out. They go bye-bye because of minus and plus. They go bye-bye because plus and minuses, and you are left with w cubed plus x cubed. And guess what? That's what we wanted all along. And that's how we did it. Bam. And that's how I know that my answer that I put in here is correct. And it looks like the sum of cubes. That's the sum of cubes. Do not forget, some cubes, you're going to have a negative middle term. Or it's going to cancel if it's a perfect cube. And that example we've seen right here is a perfect cube. All right. I think we could try this one. I think so. Do I got the space to do it? Probably not. I'm so worried about not having the space. Let's do this one. This one should be able to give me space. Does it? All right. We could do this one right quick. So guys, for a problem like this, no, I don't know, I'm trying to be nice, but at the same time, I'm trying to be bad and make y'all work that problem out. Okay, I'm be good. So for a problem like this, when I worked out, I get 20. Because when you take one of these out, you're going to be left with something like this. Y plus 5z skirt. And that's what you're going to be starting out with. But knowing how big I write, I'm going to say this for us when we get in the classroom and make a separate video for this. But take your example of what we did here and try to apply it. No, don't worry about it. These three problems here, I'm either going to do it in class or just give you I'm doing class and I'm going to make a video of those three problems. All right, y'all. I think that's going to be it for now because I know we got a lot of work to do. All right, y'all.